My name is Davis Vaughn. I work at Posit, hard to say, it's no longer RStudio, formerly known as RStudio. And I work on the Tidyverse team. I actually used to work a lot on the Tidy Models team, but have recently kind of switched over to work on Tidyverse instead. Recently, I've been working a lot on dplyr. I also work a lot on tidyr and helped with like the per 1.0 release as well. Which I won't be talking about that today, but if you haven't seen, like per 1.0 has a lot of new things like progress bars, which are one of the things that people are really interested in. So I will be talking about dplyr 1.1. We've done a lot of work here. The title's a little bit of a lie. I'm also going to be talking about another package that I've created called IVs. Most of the time will be on dplyr 1.1, but I'll spend about 10 minutes at the end on IVs. The idea here is that this is a package for interval vectors, like date ranges, like with a start and a stop. There isn't really good support in R for this kind of stuff, but it's pretty useful in like time series work and in like, Bank of America style work. It comes up quite often. There's a lot of Stack Overflow questions that frustrated me because I couldn't answer them with our existing infrastructure, and that kind of rage motivated me to develop this package.
The best motivation.
Yeah. Rage-driven development, I think is what we call it. So with dplyr 1.1, these are the three big topics that we're going to cover today. This new operation, or this new idea called per operation grouping. We're going to talk about all of the new join enhancements that we've made. We've kind of rewritten the joins from the ground up. And then we're going to talk about these new vector functions, which are just a grab bag of new things in dplyr that are kind of like column oriented. So for per operation grouping, we're going to start with some data. You'll see these little tibbles kind of floating around throughout the talk, and these just represent a data set that we're going to be working with. This one is called just transactions. The general idea here is that we've got two companies, A and B, and each row kind of represents a single transaction for that company. It brought in some amount of revenue. So for the first row, it's company A in 2019 brought in 20 so-and-sos of revenue. Could be $20, could be $20 million, depending on how many zeros you want to add on the end. If we were to go back to like, day one of learning dplyr, you might be able to, ask this kind of question of what is the total yearly revenue of each company? This is fairly simple. You could kind of, aggregate by color and sum up the revenue here, grouping on company and year. If you were to like actually write the code to do this, it would probably look something like this. So you've got transactions and you pipe that into group by, grouping by company and year, continuing on into summarize and computing the sum of the revenue. The main things to notice here is not actually what's happening up here. It's the things I'm interested in are what's happening down here in blue. One thing to notice is that the output here is actually still grouped. You grouped by two companies on the way in, or grouped by two columns on the way in, company and year. And on the way out, it's still grouped by one of those. It's grouped by company. The dplyr default for when you're doing group by summarize is to kind of strip off one layer of grouping. And this has kind of been since day one, so it's very hard to just change this outright. But it's typically been fairly confusing for people, so much so that we've actually even added this message in more recent versions of dplyr that kind of tell you what's happening. Summarize has like regrouped by company. If you really want to change this in any way, or if you want to silence this message, you can be more explicit and specify this groups argument to summarize. So for me, I would typically in the past do group by summarize, and then I would put a comma after that revenue and then say groups equal drop. That's typically what I want. I actually don't want any groups in the final result at all. I typically kind of want this like bare tibble of transactions going in and a bare tibble coming out. In other words, I really want to do both of these things together and then forget about the fact that I did anything grouped at all. The other thing that I see people do even before we did this message was that they were super defensive in their coding, and they would do group by, summarize, ungroup. Like that would be what they would do always, right? Because if you forget to ungroup, then like 5 steps down the line, you forgot that this was the thing, and then you're like, your mutate or something is now grouped and you expected it to not be. So we were kind of frustrated by this. Me and Hadley were frustrated in particular that this just kept coming up. And we were wondering, like, is there any way to do this better? Is there any way to kind of like rethink grouping in general and say, like, can we improve on this in any way? We looked around and we said, is anyone else doing this better? Because we couldn't come up with any ideas like immediately. And it turns out the data table is actually really good at this. So data table, if you're not familiar with, is just like another way to do data manipulation in R. It's really nice that they even exist because it allows us to kind of bounce ideas off each other and we both end up improving our APIs. But the way that you do this in data table is you just take transactions and you would do a similar type of thing. You sum the revenue and then you have this by argument that allows you to specify the columns that you want to group by. The rest of it's not that important. If you're not familiar with the data table, the kind of dots might throw you off, but this is how it looks there. The most important thing here, the biggest insight is that by is specified alongside the thing that you want to do. It's not separate. It's not group by and then do the sum. By is specified like directly in line with the sum, like directly alongside of it. What that means with data table is that this is a like, bare data table on the way in, and then you compute this and you get a bare data table on the way out. They don't have like a grouped data table idea, like we have a grouped data frame idea, right?
I have a question.
Yeah, sure.
So, like in SQL, we also do like group by, right?
Mm-hmm.
So in this, like you have written the inline command. So is it necessary that we've seen in the table that we have columns, company, and year? So is it necessary to specify all the columns, or how does this work?
Let's specify all the columns, like
to we
get
have
them.
company year and the revenue.
Mhm.
So in by clause, we're specifying company and year because we want the revenue for a particular company at a particular year.
Yeah.
Suppose if we have an extra column, so but if we want that column should be taken into account, so we'll specify it. But if we do not want, if we just not put it in the by clause, is it okay?
Yeah, with data table that would be fine. It just wouldn't group by that. You wouldn't get it in the result. It would kind of just pretend like it didn't exist at all. Yeah. So we looked at this and we decided, well, that's actually a pretty great idea. Data table has a number of good ideas, and people think that we hate on data table all the time, but I think they've actually got some great software. And we've kind of said, look, like instead of doing group by as a separate statement, what if you could put it directly in line with your summarize call? It's get rid of it entirely and say transactions, summarize, summing the revenue by company and year. These look somewhat similar. You might think they do the exact same thing, and in the end, they kind of compute the same results. They compute the same sums under the hood. The actual like groups are not any different. But if you run this code, you'll immediately notice what's not there. You won't see the blue stuff that I had on the slides before, where it was grouped by company on the way out. You also won't see that there's this message that's saying, here's what summarize was doing with the groups. You have to go specify this group's argument to silence this. By is per operation grouping, and group by is persistent grouping. That's what we've decided to call by, per operation grouping. The operation here being just summarize. It's in line with your summary, meaning that I only want the groups to apply for this one summarize call, and then you can drop them back off. So we've got a bare tibble coming in, that's transactions. With by, you will always get a bare tibble coming out, like full stop. There will never be any kind of grouped data frame on the way out from a summarize call with by. That means you never have to remember to do ungroup afterwards. You never have to specify groups equal drop or groups equal keep, whatever you want. I've been coding with this and like kind of rewriting some existing code to use this. And typically you end up like deleting lines of things where it's like, oh, I forgot to do this ungroup here. I forgot to do this groups call here. And the code kind of streamlines itself kind of nicely.
Can you have multiple aggregations in the summarize?
Sure, of course. Yeah, you could always specify, like, if you wanted to compute 3 other things like the average revenue instead of just a sum. Yeah, you could have more lines inside of that summarize call and then one by at the end that handles them all. Yeah.
So would we be able to do the mutate in a similar way.
Mhm.
So if I wanted to add row numbers is a very common one that I do.
Yeah,
Right?
yeah.
I'll summarize and then add the row numbers after or something like that.
Yeah, I mean, in terms of by, like mutate and summarize both have the new by argument, so you can do the same idea there. The two big differences between by and group by, as one of them is what I've already said, by only applies to the particular verb that you're working with. And then group by is persistent in some way. With the summarize, group by is kind of persistent in that it peels off one layer of grouping, but you're still left with whatever you had. With mutates, group by, like just when you do a mutate on a grouped data frame, it keeps the exact same groups on the way out. By, on the other hand, is always bare tibble in, bare tibble out. The other thing that's different between by and group by is that, and you'll see it here, by allows you to select multiple columns using tidy select. That's just the general idea of being able to put C and then kind of like unquoted column names in there, company and year. That's tidy select syntax. It looks pretty natural here with the rest of the summarize call. Group by, on the other hand, works more like mutate. If you wanted to kind of compute a column on the fly and then immediately group by it at the same time, you could do that with group by. You cannot do that with by because it only allows you to just select specific columns. So by is purely about selection. It doesn't actually create columns on the fly. The other thing that you can do this, and I won't show it here, is that because it's tidy select, it means that you can do things like by equals starts with foo, and it will group by all the columns that start with foo. You could also do, and this has been a big pain point in the past, by equals all of the little helper, and then specify a character vector that you've stored somewhere else, and that might hold the grouping columns that you want to group by. So you don't have to kind of like inline them somehow or something strange. Like it's got some standard syntax for allowing you to store that character vector of groups elsewhere and then use it. So we could do another example. What are the top 2 transactions per company? In this case, you might want to do some kind of group by company and then use slice max here, another function from dplyr, where you take the top 2 values ordering by revenue. Rather than doing group by, we can just do by. This is another one of the functions that has gained that new argument. These are the big 4 categories of functions in dplyr that have gained by. As we've talked about, mutate and summarize have come up. You can filter by groups. This is less common, but it's still meaningful in some scenarios. And then at the bottom, the family of slice functions. There's slice, slice min, slice max, slice head, slice tail, and slice sample. All have gained by. So the natural question, of course, is, well, what happens to group by? Everyone's always worried about, like, whenever we introduce something new, what happens to the old stuff. In this case, I mean, group by has been there since day one, so there's absolutely no worry that code using group by is ever going to break in any way. It's not going away. It's not being deprecated. It's not even being superseded, which is another term in our life cycle, which means that we've discovered something better, and we're not shunting the old thing, but we're encouraging you not to use it. So it's not being deprecated or superseded right now. Maybe in like a year or 2, if it turns out that by is like the way, right? Then we would come back and take a look at this and say, maybe group by should be superseded. But all that would mean is that in the documentation, we kind of redirect people towards by instead and kind of rewrite the docs. And that any kind of teaching that we do would probably just mention by and maybe say, like, you might see this group by code in legacy code. So no worries there. Sorry, say again?
That persistence can be really useful down the road.
I mean, the persistence can be useful, but you can always just specify the groups again, right? Yeah. Most often it's end up, and again, yeah, like since it's not going anywhere, if you do want persistent grouping, it may end up being the case that we don't supersede by and just say these are 2 different ways to group, right? Which is valid. Okay, so that's everything about buy, the first kind of big new feature in dplyr 1.1.
Move on.
Yeah,
I got
sure,
One more question about buy.
sure, yeah.
So one other use case that I actually used the group by,
Mhm.
and the fact that it's kind of persistent and layered, as you talked about.
Yeah,
Is if I want to do like percent of a group total, right? So for example, using your company revenue, I might want to know in any given year, company A was what portion
of the total,
of the total revenue for that year,
right,
right? And the way I would typically write that would be kind of going back, I would say revenue divided by some revenue, if you will.
right, you'd have to do like an extra, I guess, mutate after this, or maybe another summarize or something like that after this, right? Like you'd follow it up with the fact that this is still partially grouped. Is that what you're saying?
Exactly. And then you can do it like that. And can you kind of do that type thing, or is that another use case for the group?
So,
versus
yeah.
thing?
I think that was the original motivation of why it works the way that it does with the like one layer peeling off at a time, because people do like sequential roll-ups is kind of what you've said there, where it's like you compute one thing, but then you still have multiple company values, like so you might compute another thing by company after that,
Right, exactly.
ignoring the year at that point, since you've kind of handled it in that first summarize call.
Yeah.
And that's reasonable. The way that we tell you to do this with buy, if this works for you, then continue to do that, right?
Sure.
The way that we tell you to do this with buy is that you would specify by company and year, and then do whatever your follow-up summarize or mutate call is by company, right? Like you would just specify by one of the variables instead of two of them. So
Oh, interesting. But then I would lose the first couple columns, right? So if I did another summarize by company, I'd only end up with my end tibble, right, would be company and then revenue, right? So in this case, I'd be.
that would happen here
74
too.
and-
That would happen here too. That happens with the existing way as well. Because if you take this result right here and just call another summarize on it and do something with revenue, you lose year.
Right, is it like, say we take company B as probably the easier example. The last row, 30 plus the 10, there's
Yeah.
40, so 75% is what we want.
Yeah, I'd want another row or another column that had like 0.75, right? To know that, for example, if like 70% or 75% of their revenue came from 2023 and 25%, like in line with this,
Gotcha.
like of all of the total revenue that company got, how much came from each year.
Gotcha.
Right? And so that's how I use the layering in the past.
So that would be this summarize followed by a mutate. Then,
Mutate,
yeah.
yes. that's
And
right.
if you did mutate by company, it keeps all the columns
Got it,
that are
okay.
there. It will just add that fourth one, which is like percent revenue or
Got
whatever
it.
you want to call it. So you get everything.
Yeah,
Um,
that will be better because then it'll be explicit. And you don't have to just magically know that
exactly.
it's peeling off a layer.
Yes.
Right?
Yes.
Because that's very confusing. When I learned it, I remember it being very confusing to just know that, okay, it's going to take off the first, and the order mattered of the group by at that point,
Yeah.
which I also hated.
Yeah, exactly. That's the other big thing. Is like that's very much implicit in that peeling off, is that it's the outermost one that peels off, meaning that what you just said is very important. The order matters. It's very hard to teach as well. Like, how do you teach people that these like groups are peeling off when they can't see them, right? You can kind of see it here, but like you can't actually see the groups anywhere.
Cool, thank you.
Yeah. Yeah, so yours would look like, let's see. I'll show in a minute. Would look like.
Right, yep.
And that would keep all of the columns that were there before and would add this one new percent column where the operation is done by company.
Yeah.
Which, yeah, I think it's nice that it's explicit, right? And
Yes,
in my head,
100%.
yeah.
Before we do that,
Yeah.
we're talking about SQL before. I think what like made me fall in love with dplyr originally is like, now think about the sequel you have to do to like go write this and replicate it, right? You're like doing two different things and you've got to merge them together. It's like nested within things. It's long. It's messy. I think it's why I just love dplyr. Like just how compact it is and readable.
Wow. And the nice thing is that you won't have to think about that if you use dplyr. It's actually already, it just released today and it's already got support for by. So it already knows how to translate this to SQL for you. Any other questions on by? We'll move on. So the next big section is on joins. I spent a lot of time like rewriting these from scratch because they're a little bit limited in what they could currently do, which might be surprising to some of you, but we'll take that transactions data set that we were just using before, and all I'm going to do is just add this new company's data set over on the right. It's pretty simple. The story here is that we've got this company name over here, but really that's just the shorthand name for the company. It's A or B, but really that lines up with Apple or Boeing. And companies is kind of our other data set that encodes that information. So you might want to join these up so that you have like one line here where it says A and it actually says the name of the company, Apple, alongside its year and revenue. And if you wanted to do a join like that in the past, you'd probably do something kind of like this, like inner join, in this case, transactions and companies, joining by where on the left-hand side, it's company, and on the right-hand side, it's ID. So you've used this kind of slightly awkward named character syntax where you've got a named character vector where the name is company and the actual data in the character vector is ID.
It's interesting to see that by can serve the purpose of group by.
It is. It is. This is kind of a historical accident that it does this, but it's hard to find a better name, honestly, than by for both of these. But it is kind of awkward. Luckily, we would never do any kind of inner joining by groups, so you wouldn't have need both bys. So, anyways, I was, kind of frustrated by this and the fact that this is a little bit limiting, which I'll discuss later. But what we've come up with as kind of an alternative to this kind of strange named character syntax is something called join by, where now you can specify expressions like inside of join by rather than a named character vector. It's the same general idea as before. Companies on the left-hand side, so you specify it first equals ID from the right-hand side. And now you can use just typical like R syntax for specifying equality rather than the kind of strange named character vector stuff. You also don't need to quote ID anymore. What's hidden in here is that join by kind of now allows you to do arbitrary-ish expressions inside of your by condition, which is going to come in handy a lot later, or a little bit later. To make this slightly more complex, we're going to add one extra row and one extra column to companies. The story now is that, well, in real life, company names change, right? Companies buy other companies. So let's assume that in 1916, Boeing was founded, which is actually real. I did look that one up. But we're going to make up the next row that in Amazon, or in 2022, let's say that Amazon bought Boeing. So it's no longer called Boeing. Amazon wanted to get into the flight game, so now it's called Amazon. What that means is that the ID is still B. Like if we're linking it back to something over here, it's still B. But if we did actually want to join these two tables together, ideally in 2021, it would be linked to Boeing because the name hasn't changed yet. And the transactions for 2023 would be linked to Amazon because that's after the name change. That would be the ideal scenario. Now, if you tried the same inner join that we had before, where you're joining by companies equaling ID, the first thing that you'll notice is that we actually went from 6 rows in transactions up to 9. This is in general kind of a very like red flag in most people's heads when they do a left join or they do an inner join. they expect to get kind of the same number of rows that they started with. And we've gone up to 9. This is actually so surprising that in dplyr 1.1, we have now added a warning when this kind of thing happens. It means that there are multiple matches somewhere along the way, like one row in X has matched multiple rows in Y's somehow. It will actually tell you the first occurrence of this situation, where you can go back and look at it if that was an actual problem. This is technically the SQL default behavior. Like, this is what happens when you do an inner join in SQL, and it doesn't complain. So if you do want this, and people will want this, they can go back and set multiple equal all explicitly, and that will shut this warning up and make it very clear that this is a join that like is expecting to have multiple matches.
It's a very real common problem with DOR.
Yeah.
Like this, absolutely. I love that.
This is one of our 2 new quality control, I call them quality control arguments for the joins. The other one we won't talk about very much, but it allows you to catch unmatched rows as well. So this is like the case of having too many matches. There's another one that allows you to catch when you expected some matches and they didn't happen. So the problem here, at least one of the problems here, is that if you looked at like these 2 rows in blue, this was just that one, these are really just that one row of transactions from before. It's company B, year 2021, revenue 10. But because it matched 2 things in companies, you end up with 2 rows as a result. So you end up with it somehow matching both Boeing and Amazon, when really the year was 2021. So the name hasn't changed yet. So ideally, we only wanted that row to match Boeing. This kind of thing where you get multiple matches happens 3 times in the data set, which explains why we went from 6 rows up to 9. Obviously, that makes us kind of sad. So we could take a closer look here and like kind of figure out what went wrong and maybe refine our join condition a little bit. Looking again at B 2021 and seeing that, oh, well, because we matched up just the company ID to that ID over there, well, this is B, those 2 are B, obviously they're going to match both. Again, ideally, we would like it to not match that Amazon row. It would only match Boeing because the name hasn't changed. You can sit here for a little while and think about it and, get your pen and paper out and kind of figure out what could we use to make it not match Amazon. And what you might come up with is that we could use the year in the cents column as well and do this kind of little inequality check of saying, well, 2021 is greater than or equal to 1916. So that one's good, but it's not greater than or equal to 2022. So that one, like the name change hasn't happened yet, in other words, and that would eliminate that Amazon match. You could generalize this a little bit to just plug in the names instead of the columns, year greater than or equal to cents. So the general idea is, well, maybe we could add this into our join somehow and have it understand that you want matches where company lines up with ID and year is greater than or equal to cents. This is known as an inequality condition. And then as of dplyr 1.1, you can now embed these directly inside of your join by condition. So this isn't completely right yet. You'll notice we still have 8 rows. We've lost 1, which is good. And in fact, B 2021 now only has 1 match. It is just Boeing, which is exactly what we wanted. 2021 is greater than or equal to 1916. So that check is working out. But we still have, seems like 2 rows that aren't working quite right. It's these 2 still are kind of sticking around. B 2023 with a revenue of 12 is still appearing twice. And it actually kind of makes sense if you just look at the checks that we added. 2023 is greater than 1916 and it is greater than 2022. So that check didn't fix that problem in particular. So we're still a little sad. So if we were to look at B 2023, maybe we can figure out, like, can we refine our join condition even further to make it so that we get the kind of join that we want? Again, we just kind of discussed this on the previous page, but the problem is that if we did our little inequality analysis, you get true still for both of these. When in reality, we kind of want the flipped scenario now. 2022 is when Amazon bought Boeing, and because this transaction happened in 2023, we really only want the most recent name change when you actually do the join. You want this to only match up with Amazon and not Boeing anymore. So we'll have to think about how you can do that. Again, you could, pen and paper, figure out what the heck you're going to do here and figure out how you can flip that first condition to false. And what you might end up realizing is if you say it out loud a couple times, you'll understand that the reason you like the second match over the first match is because 2022 is closer to 2023 than 1916 is. In other words, like it's only 1 year away rather than 1916 being 107 years away. It's the most recent name change. It's the closest name change. And the reason I stress this kind of closer idea is because that's how you're going to represent this inside of the join. You can wrap binary conditions with this little helper called closest, and it will eliminate all of the matches that are farther away than some other match. What this does is it takes an individual value of year, finds all of the places where it's greater than or equal to since, and then eliminates all of those down to just one that's the closest match. So you've got 6 rows here in our result, which means that things are looking pretty good. You'll see that B 2023 revenue 12 only matches up with 1 row. It's the 2022 one, which is correct. It's Amazon, the most recent name change. And you'll see that things are looking pretty good. This closest idea, if you're used to data table, is known as a rolling join. The reason they call it rolling join is because you've taken 2022 and you've rolled it forward to match up with 2023. You can also do rolling joins the other way, where you kind of roll the following match backwards, which also works depending on exactly what you need. It wouldn't give the same results here, but you could do that by saying like year less than since, and then take closest as well, and it would roll the following one backwards. Sound good? Any questions?
Just a comment.
Sure.
This is not academic. This is something we have encountered too. So, our code is probably like 300 lines of code to deal with the problem. So we, here's a scenario. We have, people that apply for a credit card and think like they come in, the application comes in and we know who they are, but the data we need to make a decision is sitting in all these different tables and databases. So it's like we tell this one database, hey, give us the income for this person, and tell this other one, like, tell us about their like existing credit cards with us, and this other one, their deposits, and we need the credit bureau data too. And so we kind of make that call and we're waiting milliseconds, seconds maybe at most pass. We get in information and it's timestamps. So we have to work with. They're like all these like millisecond based timestamps. So things are coming in. But it could have been that like we've been working this application for like a few days. We had to ask them like, oh, can you go up to this thing, or they can give us enough information. So like if you're looking in the data, there's like multiple entries. Like someone's income may have been changed as they added a spouse or something. And then say maybe even later, we're doing a fraud investigation, week or two later, and we're re-polling bureau data. Who is this person? And so this idea of like, when we're trying to say, okay, when we made the decision, what information we have, is there can easily be, like 2 times we pulled it before the decision, another time we pulled it after. So I need the one that's like closest to when we made the decision right before it, to replicate what was all the data we had when we made that call. So the code we wrote for that is just messy, huge, and takes a while to
sure.
And there's one line right there. So
I think that rolling joins are actually more useful than just general inequality joins, because generally you do want like only the closest match. Like if you just, and a lot of And a lot of data frames, if you just did year greater than or equal to since, it will match thousands of rows, like 1 year and like thousands of rows before of since. And typically you only want like the closest one. So this, I think closest will be a very popular helper when you're doing any kind of inequality join.
I was answering the question in my head, I would have said max since is the additional thing I would have
Yeah,
added in
yeah.
to that logic to make it the same.
We wanted a word that was useful for both the preceding and the following match. And like you'd either need like max or you'd need min, like depending on the scenario. I did actually have that as like one of my original drafts. It's like, do we wrap the whole thing in max or do you wrap the whole thing in min? Well, it depends on if you're using greater than or less than. You have to decide. So closest, it's one word that means the same for both. So, but that's the general idea for sure. So these are the kind of newish things that you can do with joins in general. We've talked about most of them. With equality joins, these are joins that you've always been able to do with dplyr, but now you can use join by. Inequality joins are new. That just happens anytime that you've added some kind of inequality condition, greater than, less than, greater than or equal to, or less than or equal to. Rolling joins is if you wrap at least one of those in closest. And then we won't talk about these, but I think these are also pretty cool. They're called overlap joins. They're just special cases of this inequality join, but they're really popular in both time series and genomics. The general idea is like I have a date column in one of my tables, and I have a range of lower and upper bounds in the other table, and I want to match anytime that date falls between the lower and upper bounds of the other table. Overlaps is pretty similar, except now you have two sets of ranges, lower and upper in my left-hand table, lower and upper in my right-hand table. And if those ranges overlap at all, that's a match. That's what's popular in genomics. And then within is kind of a variant on that, where it's like lower and upper has to be completely inside of the lower and upper of the other table. But again, these three are just special cases of binary conditions. It's just a matter of specifying the columns with the correct less than or equal to or greater than or equal to sign. This is a red-headed stepchild called cross join that is been possible in dplyr with through like left join, right join, those other join functions by setting by equals character. That's hard to remember and awkward and doesn't really necessarily fit with what join by is trying to do. So we've moved that behavior over into cross join instead. You can still do by equals character if you want to for a little while, but that will currently trigger a warning saying like go use cross join because it's a much nicer way to just specify a cross join. It's also a little bit faster and it will translate to nicer SQL code. So.
In join by, is it like, let's say you had a scenario where your key is a string, but one table spells something like slightly different. Can you put in like regex stuff within join by, or like some people spell my name two different ways. If I was joining on my name, could I put in something that say like it's spelled correctly in this table, but in this table change this letter to this, and then your join be great?
No, so with join by, there's like a very limited set of things you can do, and it's actually mostly what you see here. It's like this special little like domain specific language that you can't just put whatever you want inside of join by. It's like equality, those 4 inequality operators, and then these like 4 helpers. It's basically the only things that you can use. So it's a small little language here. For that,
I just want to fix spelling.
yeah, you might have to do that beforehand to make it match exactly, essentially.
Cool, thank you.
Now, also assume that this takes just the AND operator behind the scenes, or does it also work with like you have scenarios with the OR, you want like a particular condition, either this to be true or the next one. That's the
Yeah, like with the essentially, if you separate by comma, then that's like it's ID, and like the IDs are the same, and date is greater than since, and whatever extra conditions you might add on the back. We've thought in the past about whether it would be useful to add OR conditions as well. It hasn't been a popular enough request that we've needed to do it. But this like join by idea was actually the most popular dplyr issue going back like 7 years, something like that, with like 140 thumbs up on GitHub. So happy to get that one done. Any other questions on the joins?
The comment would also use the between idea in very messy code without, so it's useful.
So we'll move on to two, I think, useful vector functions that we've added to dplyr 1.1. One of them is called consecutive ID. This is based on another data table function called RLE ID. I think it's just one word, RLE ID. And then the other one is called case match, which is a kind of variant of case when. I'm sure people are familiar with that. For consecutive ID, we're going to need some more data. So at our studio and at, well, posit, it's tough, man. We have these quarterly calls and we do them over Zoom because we're all remote. And Zoom is actually pretty neat in what it can do here. It can record the name of who is speaking, and then it can record the text as well of like what they said. It's probably fairly easy for Zoom to actually record this information, but it's cool to us. And Hadley was working with this, and the general idea is like Hadley said, you know, I'll never learn Python. And I said, you know, aren't you speaking at PyCon, which he did do, but he did not learn Python to do it. And he said then 3 things in a row, you know, so that doesn't influence my decision. I'm not budging. And the way that Zoom recorded this is, you know, if he paused it all between saying those 2 sentences, it might record them as separate lines. But he was working with this data and he kind of wanted to flatten each continuous thought into just one line so that, you know, he said these 3 things in a row, but really when you're working with the data, you might want to just like string squish this down to one line that all just says, so that doesn't influence my decision, I'm not budging. So those 3 rows gets collapsed to 1. In theory, that looks super simple. You might try to group by name and then squish those together. The problem is that he also spoke up here, right? And you don't want I'll never learn Python to be squished with those 3 lines as well, which makes this rather difficult because now you don't have, there's no other columns to group on. So you have nothing that you can really use to group 1 separate from 3, 4, and 5. And that's where a consecutive ID comes into play. The idea behind this function is that you can give it 1 or more columns and it will create an identifier based on the unique runs that it sees. So Hadley appeared once, got an ID of 1. The name changed from row 1 to row 2. So Davis is an ID of 2. The name changed again to Hadley, gets an ID of 3, which was repeated 3 times. So all of those get an ID of 3. The name did not change between these 3 rows. Mara gets an ID of 4, and then I spoke twice, so I get 2 IDs of 5. This is really cool because now this row and these 3 rows have different IDs, but these 3 rows all have the same ID, which means it's something that we can now group on to then squish that text column down into 1 row. So we'll do that here. Summarize, string flatten, collapsing with a space. Doing it by ID, that's really the real trick. And then you get row 3 here, which is kind of everything you wanted collapsed down. I've also just drug along the name column, which is generally what you'll want to do whenever you use consecutive ID. Things that you create the identifier from, you'll also generally want to group by those columns just so they get drug along at the end. They don't actually affect the group indices here. ID is enough to kind of specify the groups fully. And then name is just in terms of creating the groups, it looks like duplicative, but for us, it's useful to have that column along at the end. Make sense?
Yeah.
I think this one's useful.
Yeah, so quick question.
Mhm.
A real world thing where I've done something similar is doing call center analytics, right? Where maybe I call in and get transferred, right? And then maybe call in 3 days, 4 days, 3 months, whatever, later, differently, right? And if you were looking at it for me, you'd want to group everything that's kind of within a set time band.
Yeah.
To be like one kind of, I don't know, experience journey set of things, right? Maybe the same thing could go for credit cards, right? You're applying once now, 3 years later, you also apply again, right? Within some sort of time band. Are you able to do that within the consecutive IDs based on like a kind of a time or a date column or something like that?
There's probably a way to manipulate that like time range into You know, actually, I think you just wait until the IV section. I think that will handle that for you, actually.
Yeah.
So now that I'm thinking about that a little bit more,
Yeah. But that's exactly what I thought of. It's like, I have spent a lot of time trying to do exactly what you've
yeah,
done here almost, but I just needed that, like, hey, multiple calls within 3, 4, 5 hours of each other.
Yeah.
To kind of label that as like, hey, this is the ID.
Yeah.
that I want for that like section. Okay, cool. Well, one more question.
all right, so that's consecutive ID. Next, I'm going to talk about case match, but we've also made some enhancements to case when that are worth mentioning. How many people have used case when? Probably everybody, everybody that actually uses like dplyr and stuff. So yeah, this is a very, very popular function. The general idea is that you could take this vector x at the top and say, when x is greater than or equal to 10, I want to replace the value with large. So 12 in this case gets replaced with large. When it's greater than or equal to 0, I want to replace it with small, 1, 6, and 0. And then, you know, I wasn't expecting anything else. So if it's less than 0 for somehow, then I'll put NA. And then anything not captured just kind of falls through. If you've used case when enough, you know that you actually get an error in this case because I've forgotten to specify a typed missing value instead of just using the typical like logical NA. This is one of the really rare cases in R that you actually have to care about what kind of missing value you're specifying, and we didn't like this. So you don't have to do this anymore. This is dplyr 1.1. So that's the first nice thing, is that we fixed that problem. So now you actually get all the values that fall through as you expected. Mainly, you just don't have to use NA character anymore. The other thing that you've probably done with case when is that you've tried to specify some kind of default fall through value at the end by saying this kind of interesting looking like true tilde default value. If you haven't captured anything with these first 3 conditions, then put other. So you see other there for -5 and -2, which weren't captured by everything above. This is also awkward. This is hard to teach, actually. How do you explain what true tilde does to anyone? And then besides just saying like, it's the default, do it. And it's also got some kind of strange recycling rules. Like these are vectors the same size as X. This is a vector of size 1. So like which one wins in terms of like what the size of the result will be. So we've changed this. So now you have an explicit default argument that you can use instead. We really prefer this. Like the true tilde stuff will still work for some time to come because you can't just break everyone's code. But default is what we've already changed all the documentation to. So any like new code that you write, we really prefer that you use default.
Do you have to put it last, or could I put it first?
Wherever you want, but it won't make much sense to put it first because it is kind of the fall through at the end. It's like a switch statement, right? It's like the last thing that gets caught. So I see what you're saying is like, if I put it first, would the other conditions even matter? Is that what you're trying to say? Or
like the 10 and the 0 makes a difference, like which one you
Yeah,
do it, right?
yeah.
In some cases it can if you have overlapping conditions.
This one will always run at the end, essentially, no matter where you actually specify it in the function call.
Got it.
Yeah, that's a good question.
Try to bring it.
Yeah.
That's why I do.
Okay, so lastly, this one is actually a lead up into case match, providing a little bit of motivation. So we've just got some countries here, and the idea is that I want to remap these into their specific continent. USA, Canada, Mexico get mapped to North America, so on. This is a pretty popular type of case when where you've just got one vector and you're kind of remapping all of the values to something else, grouping them along the way. There's a lot of repetition though. It's like X in so-and-so, X in so-and-so, X in so-and-so. It's actually so common that in SQL, it has its own special name. I think it's kind of insulting. It's called the simple case statement, as opposed to like with all the logical vectors, you have a searched case statement, which is a much fancier name, but it's a very common thing to do. So we've decided that you could take some of that repetition out by allowing you to specify the vector up front. And then with this new case match statement on the left-hand side of the tildes, it's no longer logical vectors, it's just values. So any kind of values that you want to match to North America, you would put on the left-hand side. It would say, are these values, or where in X is it these three values, put North America. Where in X is it France and UK, put Europe, and so on with China and Asia. Works the same way as what like Greg was bringing up in terms of the previous slide, where it was like, if this one and this one both had matches in X, the first one wins, it's whichever one it finds first. But that probably won't come up quite as much when you're doing kind of this like manual recoding. So. The other things that you can do are similar to the other new features of case when. You've got default. You'll notice that I didn't capture Russia there at the end just because maybe I made a typo or maybe we didn't know. It fell through as unknown if you were to use the default argument. And then I think this is kind of nice. You can just put NA on the left-hand side. You don't need like is NA X from before. You just say whenever it's NA, put missing. Any questions there? So that is everything about dplyr 1.1. I'll talk about IVs next. Is there any other remaining questions about dplyr before we move on? The release comes out January 27th for that one. So this is not out yet, but it will be very soon. So IVs is a package that is used for interval vectors, IV interval vector. I wanted to call it IV, but that package was taken on CRAN, so I had to call it IVs instead. The motivation for this one is that we're all going to be in an apartment together, or at least some of us. And me, Greg, Ben, and Robbie are all going to have lived in the same apartment at some point over the course of approximately 10 years or so. Different ranges. We were there at different times. I was there first from 2014 to 16, and then Greg showed up for some. He came and left. Robbie came and left. Ben was there once. The other thing that you'll need to know about this little data set is that end is exclusive. So I was there for all of 2014 and all of 2015, but none of 2016. Like 2016 1-1 is really what that end means, and it's like so none of 2016 was I there. So IVs allows you to represent this start and end column as one unit. Like really, they should always be tied together, and really start should always be less than end. And it actually will enforce that for you if you wrap them up together inside of an IV call. This allows you to create one column, which I just call range most of the time. And you'll see that it has kind of the same thing that I was talking about. The left-hand side has a bracket or kind of inclusive range, and the right-hand side has a parentheses for exclusive. This is just a right open or a half open interval. So this is neat, but you might ask, like, why is that useful? What can I do with this? And I'll have a couple common questions that might come up that we can answer with IVs. But first, I want to show this information in a slightly different way. I think this is rather hard to digest just by looking at it. So instead, I like to put these problems on kind of a number line to explain them. I think it makes it a lot easier to understand. This is the same information as represented as before, 2014 to 2023 at the bottom. And it kind of shows when we were there in the apartment. Me, Greg, and Robbie were kind of there first. There's this gap of time with no one. Then Robbie and Greg were there at the same time for at least a little bit of it. Another gap, and Robbie was by his lones himself there at the end. One of the questions you might ask here is, if you were the landlord, you might want to know, like, what is the rolling number of people in the apartment at any given time? So for 2014, there was one person there. It was just me. For 2015, there were two people, me and Greg, and so on as you go on out. You could imagine using actual dates here instead, or month precision or something like that. And IVs can handle that just fine. It doesn't have to be an integer. But in this case, we'll keep things simple. If you actually kind of put the numbers on the number line, this is what it would look like. So this is kind of the result that we're shooting for, where 2014 would match up with 1. If you wanted to do this like with existing dplyr code, it's actually quite hard. It's not really set up for handling these kind of like range situations where one range like reaches into another row and kind of looks and sees like where do things overlap. So we needed kind of a new toolkit for this kind of stuff that still works nicely with dplyr. You do this in IVs using IV count between. All of the IVs functions start with IV to make it kind of easy to know that that's where they're coming from. I've created this year column separately, just on my own. It has the minimum year up to the maximum year that we've been discussing, 2014 to 2022. You put in that year column first, and then you put in the interval vector range second. And what this will do is kind of work through each year and say, how many times does 2014 fall in any of those ranges over there? It falls in it once, just mine from 2014 to 2016, so it gets a count of 1. 2015 falls in mine, and it falls into Greg's first range, so it gets a count of 2, and so on, so you get your rolling counts like before. There's another question you might ask as a landlord is, when was the apartment occupied at all? You might want to know, how many people were there, which isn't like what we just asked, but you might want to just have a general idea of when was it occupied, represented in these like nice compact ranges. That would look something like this. And that's the result that we're shooting for. 3 individual ranges. One is 2014 to 2017, 19 to 21, and 2022 to 23. In this case, the way that you kind of get this is that you kind of have to say it's the minimum of mine and the maximum of either Robbie's and Greg's for that first one there, and then you kind of squish all that together, and that becomes your group, is what I call them, your interval group. Again, this is kind of hard to do with your existing dplyr toolkit. It's not set up to know about like overlaps like this. So it's really easy to do this in IVs. You use a function called IV groups. You just specify the range column, and you end up with these 3 rows that we were looking at before. All this does is go through, and for all of the ranges, it merges all of the overlaps together. And this is what you're left with. These will always be distinct ranges that never overlap with each other. If they did, they would have been combined. What's in red is probably new to most people. This is another verb in dplyr 1.1 that I haven't talked about. It is not mutate, it's not summarize, it's tentatively, but probably finally, is called reframe. If you are familiar with summarize, you'll know that returns 1 row per group, right? But sometimes you need to do things that are a little bit more generic. You need to return an arbitrary number of rows per group. So in this case, we had 1 group, it's that 1 apartment, but we didn't necessarily know how many rows were going to be returned. We didn't know how many disjoint intervals we had. If they all overlapped, we could have just ended up with 1 row there. If there were 2 sections of overlaps, we would have ended up with 2. It's dependent on the data, not dependent on the operation that you're doing, right? So that's a perfect case for reframe. But you can really just think about it as summarize, relaxed to being able to return any number of rows per group rather than just 1 row per group. But you can do all the same things. It actually even has the by argument as well. If you're like a dplyr power user, you'll know that in 1.0, we actually allowed summarize to do this. We kind of relaxed its restrictions and said that, yes, summarize can also can return more than 1 row per group. Got a lot of feedback that was a bad idea. So we have rolled that back. The complaints were generally like summarize as a name means 1 row per group, like it's a single summary value per group. So it didn't really go well with that idea. But more importantly, it could lead to a lot of bugs. If you were to accidentally return something with like 0 rows, it would like recycle that silently just because of how recycling rules work. But it led to a lot of hard to understand bugs that can come up, especially when you're a beginner learning dplyr. Since this is kind of a more special case operation anyways, it has been moved to reframe. The other thing that we kind of connect this to sometimes is an old dplyr verb called do. Allow you to kind of do anything. Kind of weird clunky syntax, but it kind of can accomplish the same kind of stuff here, where it's you have a group and you want to return something from that group. and then collapse them all together. This would allow you to do something like that. The last example here is the kind of complement of the previous problem. We wanted to know when the apartment was occupied, but now we want to know when the apartment was empty. Maybe the landlord is trying to figure out when they could have like optimized for putting more people in there. That would result in these ranges. So it's the blue ones before, but kind of flipped around. You can do that with IB set complement. Easy, takes the range, computes those groups that we saw before by merging all the overlaps, and then just inverts them. So you always get kind of the minimal result. You get those two blue sections you saw in the previous slide. So that is all I have. This was about dplyr 1.1. You've learned about the joins, you've learned about by, some new vector functions, and then we've talked about IVs. I think that one's pretty exciting. It's on CRAN already, so you can go download that one today. dplyr 1.1 will be out January 27th-ish. Thank you.